So it turns out that potential and kinetic energy are just two forms of many different types of energy. However, well, let's just say it that way for now. This real situation is always a little bit more intriguing. What are some other types of energy? What are some other things in everyday life that have the ability to do work? Yes.
Electromagnetic energy?
Yes, very good. For example, if you have a wire, well, let's do it this way. Let's say you have a waterfall. Here's a waterfall. The water's going down. What kind of energy is the waterfall? Kinetic, right? So you got kinetic energy, and the waterfall spins a turbine. So we still have kinetic energy, and that turbine spins a generator. Now all of a sudden we have electromagnetic, and that generator ships its energy over some wires, and it comes to your house, and at your house you have a hairdryer getting ready for your college class. And so let's label all the energies. What kind of energy does the waterfall have before it falls? Yeah, so up here it's got potential. It has mechanical potential because it's something that's moving. And then here it's something that's about to move. It's a physical object. Then it's got kinetic, and this is still kinetic energy here. But then all of a sudden it's just coming over these wires as what we're going to call electromagnetic energy. And it comes to your hairdryer, and what does it become at your hairdryer? Andre? Say it again.
Thermal energy.
Thermal, and which is heat, and then what else?
What else? Mechanical.
Right, mechanical, because it's spinning and blowing air. So it's turning into thermal or heat, thermal, heat energy, and mechanical again. Okay, very good. So we can add a couple things to our list here. We have potential, we have kinetic, we have electromagnetic, we have thermal. What else could you plug in at your house and have happen?
Sorry, this was just a question about the waterfall.
Sure.
So while it's moving, before it actually hits the ground or the point where it's supposed to hit, isn't it kinetic and potential?
Correct. Yes. Yeah, that's just a simplification there, because the water is flowing, so obviously it's got some kinetic, so it's got both. So what else can you plug in at your house that might give you a clue as to other types of energy? Nicholas?
Microwave.
Ooh, well, what kind of energy comes out of a microwave?
Nuclear.
No, that would be bad. Yeah. No, any other guesses? Yes?
Radioactive.
No, that is nuclear. Okay. Andre, you want to take a stab at it?
No.
Okay. All right, so what comes out of your microwave is yet more electromagnetic energy, except now it's free from the harness of wires, and it's simply radiating from your microwave into your food, and hopefully most of it's staying in your microwave and not heating the tissues of your brain. Now, anyway, so electromagnetic, thermal, what else can you plug in at your house that does something useful? That gives you a useful form of energy. Here, I'll give you a hint. Yeah, this is the sound of a light switch. Okay. So, yeah, light energy. Light, and actually, I'm sorry. Light is really just a type of electromagnetic energy as well, but, you know, it's good to say that. Okay, so you can have potential, kinetic. We can let's make a couple. Let's look at the more complicated picture here with potential and kinetic. Kinetic refers only to moving things. So, for example, kinetic is moving masses. Moving masses. But you can have electromagnetic potential energy. For example, if you take two magnets, here's a magnet, here's another magnet, north, south, north, south. So these magnets are going to be attracted to one another. If you pull them apart and hold them apart from each other, there's going to be some potential energy, but it's stored in the magnetic field. It's magnetic potential energy. There's one other type of energy we need to talk about, and so we mentioned it erroneously earlier. What would that be, Nicholas?
Nuclear.
Can you still hear me? Yes, it's still blinking. Okay. Yeah, nuclear energy. That's the other type. Nuclear energy. Now, in theory, you can go from any type of energy to any other type of energy. So, for example, we showed with the waterfall, we went from potential to kinetic to electromagnetic to thermal to more mechanical or kinetic. But in theory, you can go from any type to any other type. So, for example, when the sun shines down on you, here it is, little photons, happy photons coming down. Photons are a form of what type of energy?
Electromagnetic.
Correct, electromagnetic. So it comes from the sun. We'll talk about what that is in a minute. There's EM. There's one other type we need to talk about. Can't believe I forgot it. Well, let's give you a hint. So the sun shines down and it's helping this beautiful stalk of corn to grow. What type of energy is it storing?
Is that chemical energy?
Yeah, very good. Chemical energy. So now again, chemical energy, here's an example of chemical energy that we're all somewhat familiar with. See, we'll play Pictionary. Who can guess what I am drawing? That's supposed to be a plus sign. Just imagine it. What is that? Your battery, your car battery. It has potential energy. It's got the ability to do work in the form of a chemical spring, so to speak. It's like a wound up spring made of chemicals. So, in reality, all chemical energy is a form of electromagnetic energy waiting to happen because it's stored in the electrical fields of the atoms that are involved. Okay? Nicholas, you got to wake up. I've been threatening Nicholas that I would do this live if he kept falling asleep. Now he's getting it. But we, for all intents and purposes, we can consider chemical its own subset of energy. Okay? So then we've got this chemical energy in the form of a cornstalk, and then let's say you eat your cornflakes for breakfast. So it goes into you. So now you've got that chemical energy inside, and then you go to physics class and do work. And what does it turn into? What does your chemical energy turn into while you're in physics class? Any guesses? What kind of energy comes out?
Brain power.
Brain power, okay. That's interesting. But what would, in terms of the energies listed, how would you quantify that? What happens when you go to physics class?
Well, it's mostly mechanical, right? You're walking. You are. Oh no, that's not mechanical.
That's good. Yeah, no, it's turning into mechanical. Yes, mechanical.
So you're walking. You're writing. You're pushing papers around.
So it's turning into kinetic energy, but it's also turning into what?
Thermal.
Thermal energy, exactly. You are burning your breakfast, so it's turning into thermal, it's turning into kinetic. Very good. It's also turning into more chemical because, for example, well, anyway, it's turning into these things. Now, where did it come from? It came from the sun, but what's powering the sun? Anybody know?
Nuclear energy.
Nuclear energy. Let's talk about that for a minute in the next lecture. And after